As you settle in, allow the weight of your body to grow heavy, to be held completely by the surface beneath you. There is nothing else to do, nowhere else to be. Simply be here in this quiet space and breathe. A slow, gentle breath in, and a long, soft breath out. Feel the gentle rise and fall of your chest, a quiet rhythm in the stillness of the room. Your thoughts may come and go, like passing clouds in a vast and peaceful sky. You don't need to hold on to them. You can simply let them drift by, acknowledging them and then letting them go. Your only focus, if you choose, is the simple, soothing act of breathing, in and out. And as you rest here in this calm and quiet place, perhaps a gentle question can float into your mind, not as a puzzle to be solved, but as a soft wonder to hold. Have you ever looked up at the vast expanse of the daytime sky and wondered, in a quiet and simple way, why it holds that particular gentle shade of blue? It's a color so familiar, so constant, that we often forget to see it. But tonight, we can take a slow, peaceful journey into that blue. We can explore it not with effort, but with quiet imagination. You don't need to open your eyes or even focus too hard. The story will unfold gently, like a whispered secret, and you can drift along with it as you drift closer and closer to sleep. Our journey begins far, far away from the gentle blue of our sky. It begins in a place of immense, quiet power. Imagine, if you will, the sun. But let's not picture it as a blinding, harsh light. Instead, imagine it as a vast, silent sphere of warmth and energy floating in the deep, velvety darkness of space. It is a constant, steady source. For billions of years, it has been pouring its light out into the cosmos, a generous and unending gift. This light is not just a single thing. It is a river, a vast and silent river of energy, flowing in every direction. It is composed of countless tiny packets of light called photons. Each photon is a traveler, a tiny messenger on an immense journey. And this light, this river flowing from the sun, appears as white or pale yellow to our eyes. But within that seeming simplicity, it holds a secret. It holds all the colors. It is a perfect, balanced mixture of every color you have ever seen. Imagine a single, pure white thread. If you could gently untwist this thread, you would find it is made of many smaller, vibrant threads. A thread of the deepest red, like a fading ember. A thread of bright, warm orange, like the skin of a ripe piece of fruit. A thread of sunny, cheerful yellow, like a field of daffodils. A thread of calming green, like new spring leaves. A thread of serene blue, the very blue we are seeking. And a thread of deep, mysterious violet, like the color of twilight. All of these colors, all of these threads, are woven together so perfectly that they appear as one. This is the nature of the sunlight that begins the long journey toward us. It is a promise of a rainbow, a spectrum of colors, all bound up in a single, pure stream. Now, let us follow one small part of this stream of light, a single ray, as it leaves the warm, pulsing surface of the sun. It springs forth and begins its journey across the vast, silent expanse of space. The journey is long. It takes just over 8 minutes for this light to travel from the sun to the earth. For 8 minutes, this little packet of light, this photon, travels through an almost perfect emptiness. Imagine floating in this space. It is not cold and frightening. It is profoundly peaceful. It is a silence so deep and complete that you can feel it. It is a darkness not of absence, but of presence. A deep, soft, black velvet that surrounds everything. Here, there's nothing for the light to touch, nothing for it to bounce off of. It travels in a perfectly straight line, a tiny, determined messenger on its path. It carries with it all the colors, still woven together as white light. The red, the orange, the yellow, the green, the blue, and the violet all travel together, side by side, at the exact same speed, in perfect harmony. They are a family of colors, on a silent pilgrimage through the cosmos. As our ray of light nears the end of its 8-minute journey, a beautiful shape comes into view. It is a sphere, a marble of swirling white clouds and deep, dark oceans suspended in the blackness. It is our Earth. From this distance, it glows with a gentle light of its own, a reflected light. It looks peaceful, quiet, and alive. And surrounding this sphere, like a delicate, invisible halo, is a thin, fragile layer. This is our atmosphere. It is a blanket of air, a vast, gaseous ocean that protects our world. From space, you can barely see it. It is a whisper-thin veil around the planet. But it is this veil, this seemingly empty layer, that holds the secret to the blue sky. Our little ray of light, which has traveled 93 million miles through the silent emptiness of space without touching a single thing, is about to meet this atmospheric ocean. It is about to end its journey in a straight line and begin a new kind of dance. Let's slow down time, slow it down to a crawl, and watch what happens as this ray of white light, full of all its colors, finally touches the very outermost edge of our atmosphere. The atmosphere is not empty. It may look that way to us from the ground, but it is full. It is a sea of countless, tiny, invisible particles. They are molecules of gas. Mostly, they are nitrogen molecules and a smaller amount of oxygen molecules. Imagine them not as hard little balls, but as tiny, energetic dancers, or perhaps as microscopic, invisible bells, floating and drifting in the vastness of the air. They are incredibly small, far smaller than a speck of dust, far smaller than anything you can see. And there are billions upon billions of them in every direction, filling the space above us. They are loosely spaced with great distances between them, but they are everywhere. They form a deep, deep ocean of air that is many miles thick. Our ray of white light, with its family of colored threads, now plunges into this ocean of air. For the red light, with its long, gentle wave, the journey continues almost as before. Imagine the red light as a long, flowing ribbon. Its wavelength is long, which means the crests of its waves are far apart. As it travels, it encounters the tiny nitrogen and oxygen molecules. But because its wave is so long and stretched out, it tends to flow right past them or around them without much interaction. It's like a large ocean liner sailing through a sea of tiny floating corks. The corks are there, but they are too small to have much effect on the ship's path. The red light and the orange and yellow light next to it are the calm, steady travelers. They are less easily disturbed. They continue their journey in a mostly straight line, heading down toward the surface of the Earth. But something very different happens to the blue light. The blue light and its neighbor, the violet light, have much shorter wavelengths. Imagine the blue light not as a long, flowing ribbon, but as a much shorter, more energetic and wavy one. The crests of its waves are very close together. It vibrates more quickly. Because its wave is so much smaller, it is just the right size to interact with the tiny nitrogen and oxygen molecules. It doesn't just flow past them, it meets them. When a photon of blue light, with its short, energetic wave, strikes one of these tiny, invisible gas molecules, an amazing thing happens. The molecule absorbs the photon for a fraction of a second, an immeasurably small moment in time. For that instant, the molecule holds onto the blue light's energy. It's like a tiny bell that has just been struck. And just as a bell rings out with sound in all directions, the molecule cannot hold onto this energy. It immediately releases it, sending out a new photon of blue light. But it does not send it out in the original direction. It sends it out in a random new direction. It scatters the light. Imagine a single drop of blue ink falling into a perfectly still glass of clear water. For a moment, it is a single point, and then it begins to spread out, to diffuse in every direction, turning the clear water into a soft, pale blue. This is what is happening in our sky, on a grand and magnificent scale. Billions upon billions of times every second, photons of blue light are hitting gas molecules and being sent off in new directions. One photon might be sent sideways, another might be sent straight back up towards space, and many others are sent downwards and sideways, zigzagging their way through the atmosphere. The sky becomes a grand hall of mirrors, but only for the blue light. The red, orange, and yellow light passes through the hall like ghosts, mostly unaffected. But the blue light bounces and ricochets from molecule to molecule, filling the entire atmosphere with its glow. It's a chaotic, beautiful dance. A single ray of blue light from the sun might be scattered a dozen times before it reaches our eyes, its path a jagged and unpredictable series of steps. It is this scattered light, this omnipresent blue glow filling the air, that we see when we look up. So, when you're standing on the ground on a clear day and you look up at any point in the sky that isn't the sun itself, you're not looking out into the blackness of space. You're looking into our own atmosphere, which is filled with this scattered, secondhand sunlight. From every direction in the sky, these scattered blue photons are arriving at your eyes. It's as if the entire sky has become a giant blue lamp, lit from within by the sun's light. The molecules in the air are not blue themselves. The air is not a blue gas. It is the interaction, the dance between the sunlight and the air, that creates the color. It is a phenomenon, an effect, a beautiful illusion born of physics. You might wonder about the violet light. Violet light has an even shorter wavelength than blue light, so it scatters even more effectively. Why isn't the sky violet? There are two simple, gentle reasons for this. First, the sun produces a slightly less violet light than it does blue light. But more importantly, our eyes are simply more sensitive to the color blue. Our eyes have special cells, called cones, that detect color. And the cones that detect blue are more responsive than the ones that detect violet. So, even though there's a great deal of scattered violet light in the sky, our eyes and our brain perceive the color as a beautiful, calming shade of blue. It is a color perfectly tuned to our own biology. And what about the sun itself? When we look directly at the sun, which we should never do, of course, but we can imagine it safely, it appears yellowish white. This is because we're seeing all the colors that were not scattered away. We're seeing the red, orange, yellow, green, and the remaining blue and violet light that made it straight through the atmosphere to our eyes. All mixed back together, they look like a pale, warm white. This same principle of scattering also explains the breathtaking colors of a sunrise or a sunset. As the sun sinks toward the horizon, its light has to travel through a much longer path of atmosphere to reach you. It is skimming the earth, passing through the thickest part of our airy ocean. On this much longer journey, the light encounters far more gas molecules. The blue and violet light, which are so easily scattered, are bounced around so many times that almost none of it makes it directly to your eyes. It is scattered away, out of your line of sight. What is left? What survives this long, arduous journey through the thick air? The light with the longer wavelengths. The resilient reds, the warm oranges, and the golden yellows. They are not scattered as easily, so they are the ones that can push through all that extra atmosphere to paint the clouds and the sky near the horizon with their fiery, gentle hues. A sunset is, in a way, the leftover light of the day. It is the light that survived the scattering. It is the sky showing us the other colors of the sun's white light, the ones that are usually hidden by the overwhelming blue. But now, as you lie here, you can let go of the fiery reds and oranges of the sunset. You can return your thoughts to that calm, steady, peaceful blue. Imagine yourself floating gently in that vast blue expanse. It is not cold. It is filled with a soft, ambient light. Below you is the gentle curve of the earth. Above you, the blue fades into the deep indigo and then the black of space. All around you are the tiny, invisible dancers, the nitrogen and oxygen molecules, silently catching and releasing photons of blue light, weaving the great tapestry of the sky. It is a silent, constant process, a quiet miracle that happens every single day all over the world. The blue of the sky is a reminder of the unseen. It is a color created by the invisible journey of light from a distant star, the invisible ocean of air that we breathe, the invisible tiny molecules that dance and float all around us. It is a collaboration between the grand scale of the cosmos and the microscopic scale of atoms. And it all comes together to create a color that brings us a sense of peace, of openness, of calm. Let the image of this gentle, scattered blue light fill your mind. It is not a harsh, demanding color. It is a soft, receding color, a color you can fall into. You can let your awareness drift in this endless blue. Feel the quietness of the journey the light took, the silence of space, the gentle, countless interactions in the air. There is no hurry. There is no struggle. It is just a natural, peaceful process, a law of the universe unfolding gracefully. The blue of the sky is a shared experience. Every person who has ever looked up on a clear day has seen this same scattered light. It connects us all. It is a ceiling to our world, a canopy of tranquil color. And just as the sky is a constant, steady presence during the day, so too can your breath be a constant, steady presence for you now. A gentle anchor in the quiet of the night. Let's return to that single ray of light, that traveler. It left the sun, a mixture of all colors. It journeyed through the silent void, patient and unchanging. It met our atmosphere, that delicate shield, and there it was transformed. The family of colors was separated. The blue light was invited to a grand, silent dance, filling the sky with its presence. The red light journeyed on, continuing its path. It is a story of separation and transformation, but a peaceful one. Think of the air around you now, in the darkness of your room. It is the same air. The same nitrogen and oxygen molecules are there, drifting quietly. In the dark, they are at rest from their dance with the light. They are waiting for the dawn. They are waiting for the sun's first rays to travel once more across the vastness of space and begin the process all over again. Tomorrow, they will once again catch the blue light and scatter it, painting the sky for a new day. But for now, they are quiet. Everything is quiet. The explanation is simple, but the reality is profound. A star 93 million miles away and a sea of invisible particles working together to create beauty. It is a reminder that the most beautiful things in our world are often the result of simple, elegant, and quiet processes. There is a deep and abiding peace in the physics of the universe, an order and a harmony that we can rest in. So now you can let these thoughts go. You can let the images of light and air and color dissolve. They have served their purpose. They have given your mind a gentle path to walk, a quiet story to follow. And now, the path leads to sleep. The story is ending. The sky you have been imagining is now the dark, peaceful sky of night, filled with distant, twinkling stars. The blue has given way to the deep, restful dark, and you can give way to rest. Feel the gentle pull of sleep like a soft, warm tide. It is as natural and as peaceful as the scattering of light in the sky. It is a process of letting go of the day, letting go of thoughts, letting go of awareness itself. Allow your body to sink deeper into comfort. Allow your mind to become quiet and still. The universe will continue its silent, beautiful dance while you rest. The earth will continue its gentle rotation. The sun's light is still traveling through space, on its way to create a new morning. Everything is in its place. All is well, and you can rest. Deeply, peacefully. Rest now. Let's revisit this gentle journey, sinking even deeper into the details, letting them wash over you like a calm, slow-moving wave. There's no need to hold on to any single fact, but simply to float in the stream of the story. Return to that moment of creation, not of the universe, but of this specific light. Deep within the core of the sun, under unimaginable pressure and at temperatures of millions of degrees, hydrogen atoms are fused together to create helium. This process, nuclear fusion, releases a tremendous amount of energy. This energy, in the form of gamma rays, begins a journey of its own inside the sun itself. It can take hundreds of thousands of years for this energy to make its way from the sun's core to its surface. It is a long, slow, ricocheting journey, being absorbed and re-emitted by the dense plasma of the sun's interior. It is a very, very old energy. And when it finally reaches the surface, the part of the sun we can see, called the photosphere, it is released as visible light. The light that begins its 8-minute journey to Earth is already ancient, already a seasoned traveler. Imagine that. The warmth you feel on your skin from the sun is from a journey that began, in a way, before human civilization. It is a connection to a deep, cosmic past. This light is not frivolous. It is patient. It is steadfast. It leaves the sun as a full spectrum of electromagnetic radiation. There are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Our eyes, wonderfully, are tuned to that very specific, very narrow sliver of the spectrum called visible light. And it is within this sliver that the rainbow of colors resides. From the long, gentle waves of red light to the short, energetic waves of violet light. Let's picture this spectrum again. Imagine you are standing on a quiet shore, watching waves roll in. The red light is like the long, slow swells that come from a distant storm. They have a great deal of momentum and travel a long way. The space between one wave's crest and the next is wide and long. They roll onto the beach with a gentle, steady rhythm. The orange and yellow light are like slightly shorter waves, still powerful, still with a lot of space between them. They are consistent, rhythmic, and calm. Now picture the blue and violet light. These are like the small, choppy waves you see on a breezy day. The crests are very close together. They are quick, energetic, and seem to dance on the surface of the water. They don't have the same long, rolling momentum. They are more easily disturbed, more interactive with their environment. This is a simple analogy, a way for the mind to hold the difference between long wavelength red light and short wavelength blue light. One is a long, slow rhythm. The other is a quick, fast rhythm. Our photon, our packet of white light, contains all of these wave types, all of these rhythms traveling together. It crosses the vacuum of space, a place so empty that there is, on average, only about 1 atom per cubic centimeter. It is the most perfect silence imaginable. There is no medium to carry sound. There is no air to scatter light. The journey is pure, direct, and uninterrupted. The stars you see in the night sky are visible because their light has made a similar journey, but a much, much longer one, traveling for years or thousands of years or millions of years through that same profound quiet. As this light approaches Earth, it sees our atmosphere. Let's explore this atmosphere more deeply, this invisible ocean. It is composed of layers, like a cake. The lowest layer, where we live and where our weather happens, is the troposphere. Above that is the stratosphere, where the protective ozone layer resides. Above that, the mesosphere, then the thermosphere, and finally the exosphere, which fades away into the vacuum of space. The scattering of light that creates our blue sky happens primarily in the troposphere and stratosphere, where the air is densest. Densest is a relative term, of course. Even here, the molecules are quite far apart. Let's focus on a single one of these molecules. A nitrogen molecule. It's made of 2 nitrogen atoms bonded together. It is tumbling and vibrating gently in the upper atmosphere. It is completely colorless. It is transparent. It has no color of its own. It is simply there, a part of the vast, invisible whole. It is waiting. It is not aware, of course, but from a storytelling perspective, it is waiting for the light. And here comes our ray of sunshine. It enters the atmosphere. The long waves of red light approach the nitrogen molecule. The wave is so much larger than the molecule itself. The molecule is like a tiny buoy in the path of a massive ocean liner. The wave of red light causes the electron cloud of the nitrogen molecule to oscillate, to wobble for a moment, but it does so in a way that just sends the red light forward in the same direction. It is a minor disturbance, a slight jostle. The red light continues on its path, barely noticing the encounter. The same is true for the orange and yellow light. Their wavelengths are also too large to be significantly affected by these tiny molecules. But now, here comes the blue light within that same ray. Its wavelength is much shorter. It is closer in size to the molecule itself. It is a more comparable interaction. Imagine now that our buoy is not in the path of a large ship, but in the path of a small, quick speedboat. The interaction is much more dramatic. The blue light photon strikes the nitrogen molecule. The energy of the blue light is absorbed by the molecule's electron cloud. This cloud, which is usually in a stable, ground state, is excited. It is pushed into a higher energy state. It vibrates intensely for an infinitesimal moment. But this state is not stable. The molecule cannot maintain this extra energy. It wants to return to its calm, ground state. And so, it must release the energy it absorbed. It does so by emitting a new photon of light. This new photon has the exact same energy, the exact same wavelength, the exact same color, blue, as the one it absorbed. But it is sent out in a completely random direction. It is re-radiated. This is the heart of scattering, an absorption and a re-emission, a catch and release. And this happens not just once. The newly scattered blue photon travels a short distance and encounters another nitrogen or oxygen molecule. The process repeats. It is absorbed and re-emitted in another new, random direction. And again, and again. It is a celestial game of pinball played with light. The entire sky becomes the pinball machine. The gas molecules are the bumpers, and the blue photons are the silver balls, bouncing and careening in every direction. Let's visualize this from a different perspective. Imagine you are the size of a molecule floating in the upper atmosphere. The sun is a brilliant white source of light. Streams of photons are raining down from it. You see long, lazy waves of red and orange light drifting past you, almost like they don't see you. But then you see the quick, vibrating, energetic waves of blue light. One comes directly at you. For a tiny moment, you are filled with its energy, you glow with a blue light, and then you send that light away in a new direction. And all around you, as far as you can see, billions of your fellow molecules are doing the exact same thing. They are flashing with blue light, catching and releasing, catching and releasing. The entire space around you is being filled with this frantic, beautiful, silent explosion of blue light. It is no longer coming from just one direction, the sun, but from every direction. It is an ambient, all-encompassing glow. This process is called Rayleigh scattering, named after the physicist Lord Rayleigh, who first described in detail. He showed that the amount of scattering is inversely proportional to the fourth power of the wavelength. This is a scientific way of saying that shorter wavelengths are scattered much more powerfully than longer wavelengths. Blue light, with a wavelength of around 450 nanometers, is scattered about 10 times more effectively than red light, with a wavelength of around 700 nanometers. This is why the effect is so pronounced for blue and not for red. It is a fundamental property of light and matter. Now let's drift down through this glowing blue atmosphere until we are back on the surface of the Earth. You are lying in a soft field of grass. You are looking up. The sun is high in the sky, perhaps off to your side. You cover it with your thumb for a moment. Now look at the deep blue color directly above you at the zenith. The light from that part of the sky has traveled through the least amount of atmosphere to reach you, a relatively straight path down. It is a deep, rich blue because you are looking through a thick layer of this scattering medium. Now, move your gaze down toward the horizon. You'll notice the blue becomes paler, whiter. Why is this? It is because the light from the horizon has had to travel through much more air to reach your eyes. On its longer journey, it has been scattered multiple times. This multiple scattering tends to mix the colors back together a bit. Furthermore, the light from the horizon is also mixed with more direct sunlight that has been scattered at a low angle, and it is also passing through more aerosols, dust, and water vapor, which are larger particles. These larger particles don't follow Rayleigh scattering. They scatter all colors of light more or less equally. This is called scattering. When you scatter all colors of light equally, what color do you get? White. This is why clouds, which are made of relatively large water droplets, are white. And it's why the sky near the horizon, with its mix of Rayleigh scattering from molecules and scattering from aerosols, appears as a paler, whiter shade of blue. The sky is a gradient, a gentle painting of color. Deepest blue at the top, fading to a soft, almost white blue at the edges. It is a map of the light's journey, showing you where the path was short and the scattering pure, and where the path was long and the light more mixed. Let's return to the idea of the sunset. It is such a beautiful demonstration of this same principle. As you sit and watch the sun go down, you are watching the angle of its light change. The path length through the atmosphere is increasing with every passing minute. Imagine a runner on a circular track. When the sun is overhead, the runner, the sunlight, has to run only a short distance from the edge of the track to the center, you. But when the sun is on the horizon, the runner has to run all the way along the edge of the track to get to you. It is a much, much longer path. As this path length increases, the chances of blue light being scattered away from you increase dramatically. It's like a process of filtering. The thick atmosphere is a filter that removes the blue. First, the violet is scattered away, then the blue. Then, as the sun gets even lower, even some of the green light is scattered away. What remains, what successfully navigates this incredibly long obstacle course of air molecules, are the longest wavelengths, the yellows, the oranges, and the reds. This is the light that paints the underside of the clouds. This is the light that makes the sun itself look like a deep red orb. You're seeing the sun stripped of its blue and violet clothes, left only with its warm-colored ones. And sometimes, if there are volcanic aerosols or fine dust particles in the stratosphere, sunsets can become even more vivid. These particles can enhance the scattering of light, creating spectacular displays of purple, pink, and deep crimson that linger long after the sun has disappeared. The sky is telling a story of what is in the air. A clear, deep blue sky tells of clean, dry air. A hazy, whitewashed sky tells of humidity and aerosols. A fiery sunset tells of a long path and a low sun. The sky is a canvas, and the light is the paint, and the air is the medium. Now let this all settle. Let the physics become poetry. The sky is blue because the air sings a blue song when the sun's light touches it. The sky is blue because of a preference. The tiny particles of our air prefer to play with the blue light, to dance with it and send it in every direction, while letting the calmer, redder light pass by. It is a choice made billions of times a second, everywhere all at once. The result is a dome of color that has cradled humanity for all of our existence. It is the color of possibility, of open space. It is the color we associate with calm and serenity. And isn't it beautiful that the reason for this calming color is itself a calm and gentle process? A simple interaction, repeated ad infinitum. There is no violence in it, no explosión, just a quiet, constant, shimmering dance of light and matter. You can feel that quietness now. The story of the blue sky is a quiet story. It doesn't shout. It whispers. It unfolds with the patient pace of the universe itself. And as you have listened, your own body has been slowing down. Your breathing has become deeper, more regular. Your heart rate has slowed. You have been participating in your own gentle process of slowing down, of settling. Think of your mind as the sky. Throughout the day, it can be full of bright, direct, pressing thoughts, like the direct light of the sun. But now, as you prepare for sleep, you can let those direct thoughts pass by. You can let your mind fill with a more gentle, ambient awareness. A soft, blue sense of calm. You don't need to focus on any one thing. You can just be. You can just exist in this peaceful, mental space, just as the earth exists under its peaceful, blue canopy. The story is a circle. It begins with light, and it ends with light. It begins with the sun, and it ends with you, the observer, receiving that light. You are the final part of the equation. Without an eye to see it and a mind to perceive it, there would be no blue. There would just be scattered electromagnetic radiation of a certain wavelength. It is our own consciousness, our own perception, that completes the miracle and turns physics into beauty. And now, that consciousness can rest. It has done its work for the day. It has perceived and thought and felt. And now it deserves a period of deep, quiet, dreamless peace. Let go of the blue. Let go of the light. Let the darkness of your quiet room be a comfort. Let it be a blanket, just as the atmosphere is a blanket for the earth. You are safe. You are comfortable. You are exactly where you need to be. Drifting, floating, on a calm, slow river toward the deep ocean of sleep. Rest now. There is nothing else to do. Let's sink even further into the very texture of this story, feeling its gentle weight. Allow your mind to become a vast, open space, ready to receive these images without any need to hold them. Picture again the single nitrogen molecule, our tiny, invisible dancer. Let's stay with it for a while. It is into two nitrogen atoms bound together in a strong, stable triple bond. It is a simple, elegant, and very common molecule. Nearly 4 out of every 5 molecules in the air you breathe are nitrogen. It is the silent, unseen majority of our atmosphere. It drifts in the thin, cold air of the stratosphere. The sun is a distant, brilliant point of light. The earth below is a vast, curving landscape of blue ocean and white cloud. There's a profound silence here, a silence broken only by the gentle hum of its own atomic vibrations. A photon of blue light, having traveled for 8 minutes from the sun, is on a direct collision course. This photon is a quantum of light. It is both a particle and a wave. It has a specific energy, a specific frequency. As it approaches, the electric field of its wave begins to interact with the cloud of electrons that surrounds the 2 nitrogen nuclei. The electrons in the molecule are not static. They are in constant motion, occupying regions of probability called orbitals. The oscillating electric field of the blue light pushes and pulls on this electron cloud. It causes the cloud to vibrate, to oscillate at the same frequency as the incoming light. This is a forced oscillation. The molecule becomes, for a fleeting moment, a tiny, vibrating dipole. It has a positive end and a negative end, switching back and forth with the rhythm of the blue light's wave. This vibrating state is what we mean when we say the photon is absorbed. It is not absorbed in the way a sponge absorbs water. It is a temporary transference of energy. The photon ceases to exist, and its energy is now held in the vibration of the molecule's electron cloud. The moment is impossibly brief, lasting for about a femtosecond. That is a millionth of a billionth of a second. It is a timescale so short it is nearly impossible for the human mind to comprehend. But the molecule, as we said, cannot hold this extra energy. The excited state is unstable. The laws of quantum mechanics dictate that it must return to its lower energy, ground state. It must relax, and to do so, it radiates away the excess energy by creating a brand new photon. This new photon has the same energy, and thus the same color, blue, as the original one. It is a perfect echo, but it is emitted in a new direction. Why a new direction? Because the molecule, this tiny vibrating dipole, acts like a miniature antenna, and an antenna radiates energy in a pattern. For Rayleigh scattering, this pattern is not perfectly uniform. It radiates most strongly at a 90-degree angle to the original direction of the sunlight, and it doesn't radiate at all directly forward or directly backward along the original path. This is why the sky is bluest when you look 90 degrees away from the sun. If you stand with the sun on your right shoulder, the deepest, richest blue will be straight ahead of you or directly overhead. It is a small detail, but a beautiful one, a geometric signature of this quantum dance. Now imagine this happening over and over. The new blue photon travels a few hundred nanometers and finds an oxygen molecule. Oxygen, O2, is a little different from nitrogen. It's slightly more reactive, but for the purposes of scattering light, it behaves in much the same way. It is also small enough to scatter blue light effectively. So the oxygen molecule absorbs the blue photon, vibrates, and re-emits it in yet another new direction. The path of this single photon of blue light is a frantic, random walk through the atmosphere. It zigs and zags, bouncing from molecule to molecule, a tiny traveler with no destination. But the collective result of all these billions of random walks is not random at all. It is a predictable, uniform glow. It is the law of large numbers. The random actions of individuals, when summed up, create a stable and predictable pattern. The sky is a beautiful example of statistical mechanics in action. It is order emerging from chaos. A calm, steady blue, born from a frantic, random dance. Let's consider the light that doesn't scatter. The long, lazy waves of red light. They pass through this chaotic scene like a serene observer. They are too large, their rhythm too slow to get caught up in the dance. They are like a deep, resonant bass note playing underneath a flurry of high-pitched flute notes. The red light sees the nitrogen molecule. Its electric field interacts with it, but the interaction is weak. It doesn't have enough energy at that frequency to excite the molecule in the same way. It gives the molecule a gentle nudge, but the molecule simply re-radiates the red light in the same forward direction. The path is almost unchanged. This is why, if you were on the moon, which has no atmosphere, the sky would be black. Even during the day, the sun would be a brilliant, sharp point of white light. The stars would be visible right next to it. The ground would be brightly lit, but if you looked up, you would see only the blackness of space. There is no air, no gas molecules to catch the blue light and scatter it around. There is no dance. There is no blue song. The sky is silent. Our blue sky is a privilege of living on a planet with a substantial atmosphere. It is a gift of the air. Every breath you take, you are inhaling the very medium that creates this beauty. The nitrogen and oxygen molecules that fill your lungs are the same types of molecules that are, right now, on the other side of the world, scattering sunlight to make a blue sky for someone else. It is a deep and fundamental connection between the act of breathing and the color of the sky. We are immersed in the very stuff of the sky's blue. Let's go back to the idea of the spectrum. Red, orange, yellow, green, blue, indigo, violet. Roy G. Biv. We learned this in school. It is an ordered, linear progression. But in the sky, it is not so orderly. The scattering process plays favorites. It pulls the blue and violet notes out of the chord of white light and plays them solo all around us. Imagine the white light of the sun is a choir singing a single, powerful, harmonious chord with all voices from bass to soprano singing at once. As this choir enters the cathedral of our atmosphere, the architecture of the cathedral has a strange acoustic property. The high-pitched soprano notes, the blue and violet, are echoed and reflected from every pillar and every wall, filling the entire space with their sound. The low, rumbling bass notes, the red and orange, travel straight down the main aisle, largely unaffected by the echoes. When you stand in the middle of the cathedral and listen, you hear the soprano notes coming at you from all directions, a beautiful ambient hum. If you could listen directly to the choir at the front, you would hear the basses and tenors more clearly, because the sopranos have been scattered away from the direct path. This is the sky. The blue is the ambient soprano hum. The yellowish sun is the remaining voice of the choir. And the red sunset is what you hear when the choir is very far away, and only the most powerful, persistent bass notes can reach your ears. Now, let this analogy dissolve. Let it become just a feeling of being surrounded by a gentle, high-pitched hum, a color that is a sound that is a color. The senses can blend in this pre-sleep state. The boundaries can become soft. Consider the clarity of the blue. On some days, the blue is so deep and intense it almost feels like you could fall upward into it. These are often days after a rain, when the water droplets have scrubbed the air of larger particles like dust, pollen, and pollution. On these days, the air is cleaner. There are fewer large particles to cause the whitish miasma scattering. The Rayleigh scattering from the tiny gas molecules dominates. The blue is purer. The song is clearer. On a hazy, humid summer day, the sky is a pale, washed-out blue. This is because the air is full of tiny water vapor droplets and other aerosols. These particles are larger than the gas molecules, and they scatter all colors of light more equally. So, they're scattering red, green, and blue light all together. And when you mix red, green, and blue light, you get white light. So the brilliant blue of the Rayleigh scattering is diluted, mixed with the white light of the Mies scattering. The sky becomes a pale, milky blue. It is still beautiful in its own soft, dreamy way. The sky is a messenger. It tells us about the condition of the air we are breathing. It is a diagnostic tool of immense beauty. Let's think about other skies. On Mars, the atmosphere is very, very thin, only about 1% as dense as Earth's. And it's made mostly of carbon dioxide, with a lot of fine, red dust suspended in it. During the day, the Martian sky is a faint, butterscotch or yellowish-brown color. This is because the red dust particles are the primary scatterers of light, and they scatter red light forward toward the observer. But at sunset on Mars, the sky around the setting sun appears blue. It is the opposite of an Earth sunset. This is because the red dust scatters the red light away from the direct path of the sun, and the carbon dioxide molecules perform a weak version of Rayleigh scattering a little bit of blue light forward in the direction of the setting sun. It is a strange and beautiful inversion of our own experience. A reminder that the laws of physics are universal, but the results depend entirely on the local ingredients. But let's come back to Earth, back to our familiar, comforting blue. Let go of Mars and its butterscotch sky. Let go of the moon and its black sky. Come home to the gentle, friendly blue of our own world. The blue is a constant. It is a reliable presence. When you wake in the morning and see a blue sky, there is a sense of promise of a new day. It is a background to all of our daytime activities. We live our lives under this canopy of scattered light, and we rarely give it a second thought. But tonight you have given it a thought. You have journeyed into it. You have understood its quiet secret. And now you can rest under a different kind of canopy. The canopy of the night. The canopy of your own quiet mind. The story is told. The wonder has been explored. There is no more to explain. There is only to feel. Feel the completeness of the explanation. Feel how it all fits together so elegantly, so simply. The sun, the space, the air, the light, the eye, a perfect system, a perfect story. And now, your own story for the day is complete. The chapter is closing. The pages are settling. It is time to enter the quiet epilogue of sleep. The blue of the sky will be there tomorrow. It will be woven anew by the morning sun and the dancing molecules of the air. It will be waiting for you. But for now, your role is to rest, to let go, to sink into the deep, restorative darkness, to allow your body and your mind to enter their own state of silent, peaceful waiting for a new day. Let the last vestiges of thought dissolve like sugar in water. Let there be only the feeling of comfort, the feeling of stillness, the feeling of sleep, gently, softly arriving. Rest now, deeply, peacefully. Let us drift back one more time, not to learn but to feel. To immerse ourselves in the sensory experience of this journey of light. Let the words be a gentle current carrying you along. Imagine you are a photon of blue light. You are pure energy. You have no mass. You travel at the ultimate speed limit of the universe. For 8 minutes, you have known only the perfect, straight line of travel through the void. It is a journey of pure potential. You carry the color blue, but this color is not yet expressed. It is a promise you hold within your very vibration. Ahead of you, the delicate film of Earth's atmosphere grows. You are about to enter a new medium, a new state of being. You plunge in. The emptiness is gone. Suddenly, there are things here. Tiny, tumbling structures of nitrogen and oxygen. They are scattered like islands in a vast, ethereal sea. You are so small, and they are so small. It is a world of the infinitesimal. Your wave-like nature, short and rapid, is perfectly tuned to these islands. You approach a nitrogen molecule. Your electric field begins to resonate with its electron cloud. It is like a tuning fork causing another to vibrate without touching it. There is a moment of connection, of merging. Your identity as a traveling photon dissolves. Your energy is transferred. For a timeless instant, you are the vibration of this molecule. You're no longer a traveler, but a state of being, a fleeting, energetic pulse in the heart of a tiny particle of air. And then release. The molecule cannot hold you. It relaxes and you are reborn. A new photon, identical to your old self, bursts forth. But your direction is new. You're now heading, perhaps, sideways. Your original path, straight down towards the surface, has been diverted. You are now part of the scattering. You travel a short distance, and it happens again. You meet an oxygen molecule, another moment of absorption, of becoming a vibration, another moment of rebirth, and a new direction. Your journey is no longer a simple line. It is a wild, three-dimensional scribble, a dance without choreography. You are a firefly, blinking in and out of existence, your light painting a jagged, invisible trail across the sky. Now, imagine you are the collective. You're all the blue photons, billions of you, all performing this dance at once. The entire upper atmosphere is a ballroom. The light is no longer a unidirectional beam from the sun. It is a diffuse, shimmering volume of blue. It is a fog of light, a sea of scattered color. The straight lines have been transformed into a soft, glowing chaos. This chaos, when viewed from below, is the serene and uniform blue of the sky. Think of the energy. The sun's light is energy. The blue light is the higher energy part of the visible spectrum. The atmosphere is taking this high energy light and spreading it out, diffusing its power. It is domesticating the raw energy of the sun, turning a direct, potentially harmful beam of concentrated light into a gentle, ambient glow. The blue sky is a form of protection. It is the atmosphere acting as a great diffuser, softening the light that reaches the surface. Let's feel the texture of the air itself. It is not empty. It is a substance. It has weight. The total weight of the atmosphere is more than 5 million billion tons. It presses down on us with a pressure of nearly 15 pounds per square inch. We do not feel it because we're used to it and because it presses on us from all directions equally. This same air, this substance with weight and pressure, is the medium of our blue sky. The very thing that holds us and grounds us is also what paints the heavens above us. It is both our floor and our ceiling. Consider the journey of the other colors one more time with this new sensory focus. Imagine you are a photon of red light. Your wave is long and slow. You are a low, resonant hum. You enter the atmosphere, this sea of tiny molecules. You drift past them. They're too small to catch you, to make you vibrate in the same way. You feel them like small disturbances in your path, but they do not capture you. They do not change your direction. You are a steady, persistent traveler. Your journey is one of endurance. You are destined for the surface. You, the red photon, travel down, down, down. You might strike a dust particle or a water droplet in a cloud. These are much larger. They will scatter you, but they will scatter your blue and green brothers and sisters equally. This is why clouds are white. But if your path is clear of clouds and dust, you will arrive at the surface of the earth. You will strike a green leaf and be absorbed to power photosynthesis. You will strike the dark soil and warm it. You will strike the blue ocean and be absorbed into its depths. Your journey ends in a final absorption, your energy transferred to the world below. But the blue photon, your scattered sibling, has a different fate. Its journey may never end on the surface. It might be scattered so many times that its final direction is back up, out into space. A significant portion of the scattered blue light is lost to the cosmos. The Earth, when viewed from space, has a bluish haze around its edge. This is that backscattered blue light. Our planet is sharing its blue sky with the universe. It is a gentle, blue beacon in the darkness. Now, bring your awareness back to your own body, lying in the quiet dark. The air you are breathing in is a mix of these very same particles. 78% nitrogen, 21% oxygen, a little bit of argon, a trace of carbon dioxide. You are breathing in the potential for a blue sky. With every inhalation, you are drawing in the tiny dancers. With every exhalation, you are releasing them. You are in a constant, intimate exchange with the medium of the sky. Let the feeling of this connection soothe you. You are not separate from the world and its phenomena. You are a part of it. Your body is made of atoms forged in stars, just as the sun is. You are breathing the air that scatters the light. You are bearing witness with eyes that have evolved to be most sensitive to the peak colors of the sun's spectrum, filtered through that very air. It is a circle of connection, a loop of existence, and you are a part of it. There is no need to strive or struggle. The universe unfolds according to these beautiful, simple laws. Light scatters. The sky is blue. The sun sets in red and orange. The earth turns. The seasons change. And you, too, have your own natural rhythms. The rhythm of your breath, the rhythm of your heart, and the rhythm of waking and sleeping. It is time to honor that rhythm now. It is time to yield to the gentle, natural pull of sleep. The explanation is complete in all its layers. The scientific, the sensory, the poetic. It has been a journey for the mind, and now the mind can be still. The destination has been reached, and the destination is rest. Imagine the blue of the sky slowly, slowly fading, as if evening is coming to your mind. The brilliant blue softens to a periwinkle. The periwinkle deepens to an indigo. The indigo darkens to a navy, and the navy dissolves into a soft, velvety black. The sky of your mind is now a night sky, peaceful, quiet, flushed, and ready for dreams. Let any remaining thoughts be like distant, faint stars. You can see them, but they are far away. They do not require your attention. Your attention can be on the darkness itself. The comfortable, warm, safe darkness of your room. The peaceful, quiet darkness of your closed eyes. The deep, restorative darkness of sleep. The story of the blue sky is a story of light, but the story of sleep is a story of darkness. And both are beautiful. Both are necessary. Embrace the quiet darkness now. Let it hold you. Let it soothe you. Let it carry you into a state of profound and peaceful rest. The day is done. The sky is explained. And now there's only sleep. Gentle, healing sleep. Rest now. Let us sink one final time into the quietest part of this story, the aftermath. The light has been scattered. The sky has been painted blue. You have looked up and seen it. And now, the day is ending. Imagine the last rays of sunlight. The sun has already dipped below the horizon. The direct light is gone, but the sky is not yet dark. There is a soft, lingering glow. This is the twilight. This is the light that is still scattering in the upper atmosphere, high above you, where the sun's rays can still reach. The Earth's shadow is creeping up from the eastern horizon, a dark, purplish band. But above it, the sky is still full of this secondhand light. The colors of twilight are soft and gentle. Pinks, purples, oranges. This is light that has traveled a very long way through the atmosphere and is now scattering off the very highest, thinnest parts of the air and off of stratospheric dust. It is the final echo of the day's song, a gentle decrescendo. The blue has faded. The high-energy part of the spectrum is the first to be lost as the light source disappears. What's left is the softer, warmer end of the spectrum, itself fading moment by moment. It is the sky's way of saying goodnight, a slow, graceful transition from the energy of the day to the quiet of the night. Watch this twilight fade in your mind's eye. The last bit of pink on the western horizon gives way to deep indigo. The first bright stars and planets begin to appear. Jupiter, Venus, or Mars, depending on the season. They do not twinkle as much as the stars because they are closer. They are disks of light, not points. Their light has to travel through our atmosphere, and it is bent and distorted by pockets of warmer and cooler air, but they are steady. Then the more distant stars appear. Their light has traveled for so long, for years, for centuries, for millennia. That light, too, has just completed a long journey through the vacuum, just like the sunlight. And as it enters our atmosphere, it is also affected. The twinkling of a star is caused by the same atmosphere that makes the sky blue. As the star's pinpoint of light passes through the moving, turbulent pockets of air, the light is refracted, bent back and forth. It is like looking at a coin on the bottom of a swimming pool. The light from the star seems to shimmer and dance. It is the Earth's atmosphere breathing. The twinkling is the atmosphere's signature on the starlight. The night sky is not empty. It is full of these ancient lights filtered through our air. And the air itself is still there. The nitrogen, the oxygen, the silent dancers. They are still floating, still drifting. But their dance partner, the sun, has left. So they are quiet. They are at rest. They are waiting. The entire planet is settling into a state of rest on this side of the world. The photosynthetic work of plants has ceased. The diurnal animals have found their shelter. The world has grown quiet. This quietness is a necessary part of the cycle. It is a time for restoration, for repair, for growth. And you are part of this great planetary settling. Your body, in its wisdom, knows that this is the time for rest. It is a deep, ancient rhythm coded into your very genes. The rhythm of day and night, of activity and sleep. You do not need to force it. You only need to allow it, to surrender to this ancient, powerful impulse to rest. Let go of the need to understand. You have understood. Let go of the need to picture. You have pictured. Now, there's only the need to be still, to be quiet, to be here in this moment on the cusp of sleep. Feel the gentle boundary between wakefulness and sleep. It is like the twilight, a soft, hazy border. It is not a sharp line. It is a gradual fading, a slow dissolving. You can allow yourself to drift across this border. You can let your conscious, thinking mind recede, like the setting sun. And you can allow the other parts of your mind, the dreaming, resting parts, to come forward. The blue of the sky is a beautiful fact. It is a piece of the world's order. Knowing it does not change the sky, but it can change how you see it. It can add a layer of wonder, a layer of appreciation. And now, this knowledge can be put away. It can be stored in a quiet corner of your mind. It has served its purpose as a gentle focus, a peaceful path to walk. The path has led you here, to the edge of a deep, calm ocean of sleep. You can feel the gentle waves of drowsiness lapping at the shores of your awareness. Each wave pulls you a little further out. Each breath is a wave. Breathing in, a gentle swell. Breathing out, a long, slow release, pulling you out into the deep. Do not resist. There is nothing to fear in this ocean. It is a place of peace, a place of restoration. It is where your body heals, where your mind sorts and files the day's experiences, where your energy is replenished. It is a gift you give yourself each night. The story of the blue sky is finished. It has been told slowly, gently, repeatedly. It has been a lullaby of physics, a nursery rhyme of the cosmos. And now, the music has faded. All that is left is a profound and comforting silence. Rest in this silence. Let it fill you. Let it be the final sensory input you notice. The absence of sound, the presence of peace. The world will continue to turn. The sun's light is already streaming toward the other side of the planet, creating a sunrise, painting a sky blue for a new morning. The cycle is constant. It is reliable. You can trust it. You can trust that the morning will come. And you can trust that, for now, your only task is this deep, profound, and peaceful rest. Sleep now. Let go. Sleep.